So we're here to talk through this LITS puzzle by Chris Green. One thing I see right away is there are a lot of snake-shaped regions. What I mean by that is one by one cell wide regions that sort of come around, and there are places like this corner where they're somewhat cramped together. Sometimes when those snake regions sit side by side, you can do things like shade in parts of one and then see eliminations in the other. What I see right away is, for instance, if I put in cells and starting from this cell of this region, I form an I tetromino. That marks this cell off, which forms another I tetromino, so this is no good. The same logic would work out for these four cells, which would force another I, and so we get to where we can mark off this cell. Shading a further tetromino from here is going to mark a 2 by 2 square, and so we get to where we have all these cells eliminated. Get back to these cells now needing to be part of a shaded group, and if I shade this all the way to this cell, that's going to form an I with another I because that cell will be unusable. You'll form a 2 by 2 square. So we form this. We cut in again one more cell. That marks this as unusable. That gives us some more positions. And that's a way we sometimes give and take, but we look at one region and get the next. Here's another snake region. It's got 7 cells open, so this middle one's got to be used. If this cell is shaded, it actually is going to force all of these to be shaded because we couldn't take these cells together. And that's going to mark this as unused and force another I, so that cell's not possible. Let's come to this side. Here's a region with 5 cells. This may have been one of the easier places to actually start here. And form this. In this group, we've got 6 cells that are left. Now a snake shape's got to take the middle 2 of those 6. If it shades all the way to here, we get an I next to another I because that cell will be marked as unused, so this isn't a good cell. This gets taken. That's not a good cell. This gets taken. We're starting to get some structure on the top of the grid where it actually looks like connectivity is going to be a key consideration. Let's actually take one more look at this region. If I take this cell, I mark this as unused, I form an L and another L, and so I actually have formed a disconnection point. So there's going to have to be some key connectivity up at the top. Let's sort of ask a question like this. Here's the G shape. This puzzle has a Grandmaster Puzzles theme. We get a lot of submissions like this. This G shape for the G of Grandmaster, if this isn't used up top, that is to say this tetromino doesn't connect through it, it's going to have to connect through the top like this. This would be the last cell of this top tetromino, so it'd have to connect like this down, and then we're stranded. So we can say that this top part of the G is shaded, so the bottom part is not. And if you look at the actual places to shade any part of this top section, we can't go further than this cell because of the 2 by 2 box, and we're going to have to form this L shape, which forms this S shape. This I and this L now have to connect and get out, so we've got to use this cell to have connectivity either here or here, which means we use this cell to have connectivity up top. If I took this cell, we're going to form another L next to an L, so the connectivity here has to come straight down, and we'll just look ahead where this was an L shape. If this tetromino comes all the way to here, it forms another L shape, so I'll just mark that off. This puzzle looks to have a lot of these look-ahead type steps like we're doing. Let's do a little more bookkeeping here. This can't be shaded. It would force a 2 by 2 square around this cell, so we have 5 cells really that are left that can be used. Those 3 all look okay. We can't say anything more about the others, except we still have to get some connectivity up to this corner of the grid as a constraint that's going to be important. These 2 cells in this larger region now actually start to form a limitation in this space where these cells can't be shaded. But notice that this shape now only connects through this bottommost region here, so there's got to be at least some of these cells shaded for this group and this group to stay connected. And so this cell here, possibly both of these, but at least this cell here will be shaded for some connectivity. So that starts to give us some opening on this side of the grid. This group needs to stay connected, so we now can form the S, and it's going to connect through this shape, and we're going to do some more around here. There's something potentially interesting going on in this lower right corner. Let's see if we can figure it out. This 5-cell region is always a T-shaped tetromino, and I actually see a really fun elimination, it looks like. Let's see if this actually makes sense. I can make an S shape, which makes this cell unusable. I can make this S shape, which also makes this cell unusable, and that's unusable because of the 2x2 group rules. And the last tetromino shape this region could be is another T, and if this is a T, then this cell is also unusable because it would force two T's to touch. So in all three possibilities of this shape, this S, this T, or this S, that cell is not used. And so there's a really sneaky deduction that set up nicely by Chris here to force this one option of the four options for this region. We get this T shape put through. We get the start of a snake shape here with these 6 cells. The middle 2 are shaded. I'll now come back to where we were doing the give and take of looking across these things again. If this cell is used, it forms an I, but it also marks this unusable, forms another I, so that's no good. So this cell is used. It's now certain that this forms an L shape. And if it forms an L shape, it needs to stay connected. If it used this bottom cell, it would have to connect through this, and you'd have an L with an L. So it's got to come over here and stay connected like this. These aren't used. This has to reach over to this shape, and if I shade all the way over to this cell, it's going to mark too many off. So this is the start of that shape. This has to come over at least one more. That means this cell's not usable, which means this tetromino in the corner has to come over and touch to it. This is now an L, so this has to be an I. Which forces the last cell to be shaded and finishes out this puzzle. So there are a few various kinds of LITS tricks here to think through. The things that were really important at the start and really throughout, we would always get these 1-cell wide regions that would be snake-like, and where shading one group will force a lot of deductions on the one that touches it. You can look at these groups together, eventually these groups together. That's one kind of thing to think through. The last really brilliant deduction was in this corner, at least in my solving path, where we had 3 options for this shape, but all of them excluded that cell. And that gave us a deduction over here that limited this cell, formed the 6-cell snake shape, and got us through the rest of the grid. So hopefully seeing a bit about how I approach this kind of puzzle, even seeing notations like these when we can split off a group that's starting to form a 2x2 square where we can't cross over and double shade cells. These are all things that will help you on the hardest LITS out there, and hopefully by getting through this puzzle, you've learned some of those tricks, and we'll see you again soon.